Hey guys, welcome to my channel, and today I'm recording Cambridge O-Level 5070 Paper 2, October-November 2021. I've already solved its part 1, 2 and 3 videos which I've uploaded on my channel, so go ahead, watch them and let me know if you have any difficulties in them. And today I'm going to be proceeding towards the last part of the paper. I've already solved all of these, the entire paper almost, and this is just the last part. So moving on to section B, question number 9, and let's start it. This question is about sulfuric acid and sulfates. Part A1 says sulfur is one of the raw materials used in contact process to make sulfuric acid. Name two other raw materials used to make sulfuric acid. Two other raw materials used to make sulfuric acid is air and water. We all know this, air and water. Whenever we are talking about contact process, we learn we go through all the reactants or all the requirements that contact process requires. Alright, so we'll go on to part 2. Name the catalyst used in the contact process. In contact process we have vanadium oxide used. Moving on to part B, the electrolysis of dilute sulfuric acid using inert electrodes produces oxygen at the anode. Define the term electrolysis. Electrolysis is basically about the decomposition of ionic compound, and this is done using electricity. Moving on to part 2, construct the equation for the reaction taking place at the cathode. Now if you look at the cathode reaction in the if you draw it, it's going to be, if you construct the equation, it's going to be something like this. So we have basically 2H plus, and okay, for a second let's assume that we do not know, since this equation I've written several times in the paper, so I'm used to writing 2 with it, but let's just consider H plus plus E minus, that is electron, and then we have hydrogen. Because hydrogen is H2, that is why we put a 2 over here. Alright, so I hope now you understand this. Now how did I know that hydrogen will be the one that is going to the reaction that is going to take place at cathode will produce hydrogen? Because if we go through reactivity series, so then we will come to know that hydrogen will be releasing. So you need to learn the reactivity series very properly. Moving on to part C, dilute sulfuric acid reacts with sodium hydroxide. A student adds 0.76 gram of solid sodium hydroxide to 45 centimeter cube of 0.2 mole per dm cube of sulfuric acid. Show by calculation that sodium hydroxide is in excess. Now for this question, we have this. The scenario of the question is mainly that a student is adding sodium hydroxide and he's adding sulfuric acid. Now what information is given to us is that sodium hydroxide is in excess, but we need to prove it. And how we're going to prove it? By finding the amount of sodium hydroxide and finding the amount of sulfuric acid. Obviously the one that will be greater in amount is going to be in excess, and the one that is going to be lesser in amount is going to be limiting. So because sodium hydroxide is already given to us that it is in excess, now we need to prove it through mathematical calculations. And for this we are supposed to do this, the whole method, to show the number of moles. I've already solved this to avoid the hassle, because you need to use a calculator in between of the paper. It takes a lot of time and all, so I just did this before, but I'm going to completely explain you. So this is for H2SO4. Alright, let's highlight it. H2SO4, and that is sulfuric acid here, and of a student at 0.76 of solid sodium hydroxide to 0.2 mole per dm cube of sulfuric acid. This is all about sulfuric acid. And if we see about sodium hydroxide, so sodium hydroxide is 0.76 grams. Here's 0.76 grams of solid sodium hydroxide. And if we see sodium hydroxide is in excess. Also about sulfuric acid, we missed this. Here we have 45 centimeter cube. So this is the concentration and volume given to us for sulfuric acid, and grams, that is basically the mass given to us for solid sodium hydroxide. Now what did I do is, since we know the formula of finding moles, so moles is basically equals to concentration into volume. So that's what I did here. Since concentration was in centimeter cube, so I divided it by 1000 to convert it to dm cube, and then multiplied it with 0.2. Why to convert it to dm cube? Because 0.2 mole per dm cube is given to us over here. You need to make sure you notice the units. So if dm cube is given here, so you must have the volume in dm cube too while you are writing in mathematical equation to keep it balanced. And then you're going to multiply it and find the answer. So it's 0.009 moles. This is the number of moles. So this is for sulfuric acid. And then if we talk about NaOH, so for NaOH we have 0.76 grams, and if you want to find the number of moles, so we are going to divide it by the molecular mass. That means we are going to divide mass by molecular mass to find the number of moles, and that is what we have done here. So 0.19, and as we can see over here that 0.019 is a greater value. That means sodium hydroxide is greater in amount as compared to sulfuric acid. Pretty simple and basic question. Moving on to part D. Aqueous sodium hydroxide is formed with ammonium sulfate. State the names of 3 products formed in this reaction. The 3 products formed in this reaction, we are going to look into them. First of all, we have water in it, and we also have, let me highlight it for you. Sodium hydroxide is formed with ammonium sulfate. So we will have, of course, water we are going to have in it. We are going to have ammonia, since it is an ammonium sulfate. It's not just any normal sulfate, it's ammonium sulfate. So whenever we have ammonium, we have ammonia gas evolved in most of the cases. And then we have sodium sulfate, that will be one of the products, and water, of course. So you need to do all of these 3 correct to attain full 2 marks. Alright, so moving on to the last question of our paper. This question is about the elements in group 5 of the periodic table. The table shows some properties of group 5 elements: nitrogen, phosphorus, arsenic, antimony, bismuth. 1.17 3. Okay, we have all this. Using the information in the table, predict the density of the antimony. If we see antimony, we do not have the density mentioned over here, so we need to predict it. And since we're talking about prediction here, an accurate value is not required. You need to write, it's not that you need to be at home and you need to learn every element's density. No, you are not supposed to do that in these kind of questions. All you need to do is go through the table and see the set pattern, see the trend over here. If you're talking about group 5 elements, that means these are all from group 5. Alright, so if we see nitrogen being on the top and bismuth being at the bottom, we have this sudden increase, we have this extreme increase in the whole density as we go down. Alright, as we go down, so we see it starting from 1.17 into 10 to the power minus 3 to 9.8. That means one is gas and one is solid, so 2 completely different states. So antimony has to be somewhat greater than 5.73 but lesser than 9.8 because we are following the trend. So you can write it, you can write either 5.74, 5.75, 5.766, 6.67, whatever you want to write, something that is below 9.8 and greater than 5.73. So moving on to part 2, suggest why is it difficult to predict the melting point of arsenic. So of course it is very difficult to predict the melting point because these are random numbers. They do not follow a set pattern, a set trend or something. Okay, and that is why. Also one more thing, I just realized in this question that when we're talking about density of antimony, if we see over here, there's a grade change and then there's another grade change. So you need to have a value that's in the middle somewhere. I'm not sure if answer that is 5.74 will be correct, because on a safe side and something that is going to make sense, because arsenic is 5.73 and antimony 5.74 will not really make a great difference. So I'll suggest you to write something in between, like 6.2, 6.8, something like this, so that we have a good difference in between them. So this is what I suggest you to do. And again, I just explained you part 2 about melting point. Moving on to part B, the structure of 2 compounds of phosphorus, R and S, are shown. Part 1 says explain in terms of structure and bonding why compound R has a high melting point and compound S has a low melting point. So compound R, as we can see, it is an ionic structure, while compound S is not an ionic structure. It has weak forces between them, and this is basically a simple molecular structure. S is a simple molecular structure, hence there are weak forces between molecules as compared to compound R, which is an ionic structure, and it has, you know, this ionic lattice. That means it has great force in between them, and the forces of attraction between them basically is very much. Moving on to part 2, explain why compound R conducts electricity when molten. When it is molten, so then its ions can move, and hence it can conduct electricity. Okay, so mobility will be there of ions, so electricity can be conducted easily. Moving on to part 3, draw dot and cross diagram for a molecule of compound S. Show only the outer shell electrons. Now if we draw this, we have phosphorus, we have 5 for phosphorus, then we have 1, 2, 3 for hydrogen. That means we are going to show 3 bondings over here, 3 like, you know, sharing of electrons, and then we have phosphorus, that is 5, so 6, 7, 8. If we draw it, it's going to be something. Okay, let me brief it out to you. So phosphorus will have 5 outer shell electron, and then 3 hydrogens will be sharing electrons with it. And we are also supposed to show those two electrons which are like not bonded with it. Okay, because 3 are being bonded. So okay, let's draw it. I think I'd suggest let's draw it, because I'm sure it will be difficult to understand. So this is considered as phosphorus. Consider this as its, or hold, I think we can just eradicate it, and let's use this. So we have 1 hydrogen here, we have the other hydrogen here. Guys, this is really random and not so perfect, so that is why make sure you guys do it better. Let me just zoom it in for you. So we'll have a hydrogen over here, a hydrogen electron here, and a hydrogen electron here. These are basically 3 hydrogen atoms which have been forming covalent bond. And then for phosphorus, we have the sharing of electron shown, and then we need to show 2 electrons are not bonded. So phosphorus is from group 5, so 1, 2, 3, 4, 1, 2, 3, 4, 5. Okay, this thing is not an electron. Okay guys, these are electrons, as you can see here, 1, 2, 3, 4. So this is how, okay, so this is how we are supposed to draw this. So let's move on to part C. An oxide of phosphorus has formula P4O10. Calculate the percentage by mass of phosphorus in this compound. If we see the mass, so we will see the total mass for it is, let's calculate it. If we see phosphorus, and then let's take a look. So let's search phosphorus. So phosphorus is 31, and we will divide 31 with the total number of total mass of the whole molecule. So it's going to be somewhat, if we add it all together, let's see, let's go up. So here we can see we have P4O10. That means it is around 200, and I just told you how to calculate it. I've told it to you in many previous videos, so it is going to be 31 multiplied by 4 and oxygen is 16, so 16 multiplied by 10. We're going to add them together, which will give us the answer of 284, and then after that we'll have this 284 over here, and for phosphorus we have 31, and since we have 4 phosphorus atoms, so 31 into 4, and then we're going to multiply it by 100 to find the percentage, basic percentage formula, and if we are going to find its answer, it's going to be 43.7%. okay, so 43.7%. sorry for that too messy work, but yeah, that's how it's going to be done. The total mark for this question was 10, and that is it. We are done with this paper, right? Are we? Yeah, we're done. So I hope you found it helpful. If you want to know about the previous questions, you have any kind of difficulty, make sure you drop your queries in the comment section down below, and you can also check out my playlist of 2021 May-June paper. I have put the link in the description, and October-November paper, again the link is in description. I have also solved other years like 2018, 17, 16, 19, 20, all these years. So go ahead, check it out, and make sure to share it with your friends. And thank you so much for watching, and best of luck for your exams.